everyone! Welcome back to my channel, TrashToTeach.
If you've ever Googled how to use Git, stared at a terminal, typed something, got a cryptic error message, and then closed the laptop in frustration, this video is specifically for you. Git has a reputation for being confusing, and honestly, that reputation is deserved, but only because most tutorials skip the fundamentals and jump straight to commands. You end up memorizing words without understanding what they actually do. Today we go back to basics. By the end of this video, you will understand what Git is, why it exists, and how to use it from setting it up for the first time all the way to pushing a real project to GitHub. And it will make sense. Not just work, actually make sense. I'm TrashToTeach. Let's get into it. What is Git? Let's start with the most important question. What actually is Git? Git is a version control system. That's the technical answer. But here's what it actually means in practice. Imagine you're writing an essay. You save it as essay.docx. Then you make changes and save essay_v2.docx. Then essay_final.docx. Then essay_final_real.docx. 3 weeks later, you have 12 versions and no idea what changed between them or which one is actually the right one. Git versus GitHub. Before we go any further, I need to address the confusion that trips up almost every beginner. Git and GitHub are not the same thing. Git is the tool. It runs on your computer. It tracks changes to your files locally. It works completely offline. Git doesn't know GitHub exists. GitHub is a website, a cloud service that stores your Git repositories online. It's like Google Drive, but specifically designed for Git projects. GitHub makes it easy to back up your code, share it with others, and collaborate on projects. The workflow is, you use Git on your computer to track your changes, then you use GitHub to store and share those changes online. Git is the engine. GitHub is the garage where you park it. There are other services that do what GitHub does. GitLab and Bitbucket are the main alternatives, but GitHub is the most popular, especially for beginners, and it's what we'll use today.
Installing and configuring Git. Let's get Git installed. Go to git-scm.com and click Download. Choose your operating system. On Windows, run the installer. The default options are fine for beginners. Just click Next through all the screens. On Mac, the easiest way is to open Terminal and type git --" version. If Git isn't installed, macOS will automatically prompt you to install the Xcode command line tools, which includes Git. On Linux, open your terminal and type sudo apt install git on Ubuntu or Debian systems. Once installed, there are 2 configuration settings you must do before anything else. Open your terminal or the Git bash terminal that installed on Windows and type these 2 commands. Replace the name and email with your own. Use the same email address you'll use for your GitHub account. Type git config -- global user.name your name. Then git config -- global user.email your@email.com. These 2 settings tell Git who you are. Every commit you make will be stamped with this name and email. You only need to do this once. The global flag saves it for all your projects on this computer. To verify it worked, type git config -- list. You'll see your name and email listed. The 5 commands you need first. Here's the honest truth about Git. There are hundreds of Git commands, but as a beginner, you will use 5 of them for 90% of everything you do. Learn these 5 first. Everything else comes later. Command 1. Git init. This initializes a new Git repository in your current folder. It's the starting gun. You run this once per project to tell Git, start tracking this folder. Command 2. Git status. This shows you what's changed in your project since the last commit. Which files are new, which are modified, which are staged and ready to commit. You'll run this constantly. It's your dashboard. Command 3. Git add. This stages your changes. It tells Git which changes you want to include in your next commit. Think of it as putting items in a box before you seal and label it. Command 4, Git commit. This saves a snapshot of your staged changes with a message describing what you did. The message is for your future self, and for anyone else who reads your project history. Command 5, Git push. This sends your local commits to GitHub, uploading your work to the cloud. Once you push, your code is backed up and visible on GitHub. Your first repository. Let's build something real. Open your terminal and navigate to your desktop by typing cd desktop. Create a new folder, mkdir, my-first-repo. Navigate into it, cd my-first-repo. Now initialize Git init. You'll see a message saying initialized empty Git repository. Git has created a hidden folder called .git inside your project. That's where it stores all its tracking data. You'll never need to touch that folder directly, but know it's there. Now create a simple file. Type echo #myfirstproject greater than readme.md. This creates a readme.md file with a heading inside it. Now run. Git status.getStatus shows readme.md in red under untracked files. This means Git can see the file exists, but it's not tracking it yet. Red means not staged. We need to add it. Staging and committing. Type git add readme.md. Now run git status again. Notice readme.md has changed from red to green. It's now under changes to be committed. It's staged. It's in the box, ready to be sealed. Now commit it. Type git commit-m, initial commit, add readme. The -m flag lets you write your commit message in line. Always write commit messages in the present tense, describing what the commit does, not what you did. Add readme, not added readme. Fix login bug, not fixed login bug. This is the standard convention, and your future self will thank you. Your first commit is done. Type git log. This shows your commit history. You'll see your commit listed with a long string of letters and numbers. That's the commit hash, a unique ID for that snapshot. You'll also see your name, email, date, and message. This is your project's history beginning to form. Now let's make a second change so you can see the workflow repeat. Open readme.md in VS Code. Type code readme.md. Add a new line. Learning Git with TrashToTeach. Save the file. Back in the terminal, Git status. You'll see readme.md is now listed as modified in red again. Git noticed the change. Git add readme.md. Git commit-m. Update readme with description. Run git log again. Now you have 2 commits in your history. This is version control in action, every meaningful change saved with a message forever retrievable. Pushing to GitHub. Now let's put this project on GitHub. Go to github.com. If you don't have an account, create a free one. Once logged in, click the plus icon in the top right and select New Repository. Give your repository the same name as your folder, my-first-repo. Leave it set to public. This means anyone can see it. If you want privacy, choose private. Leave initialize this repository unchecked. We already have a local repo. We don't want GitHub to create a conflicting one. Click Create Repository. GitHub will show you a setup page with commands. Look for the section that says, or push an existing repository from the command line. You'll see 2 commands. Copy them, or type them exactly as shown on your screen. The first command connects your local repo to GitHub. Git remote add origin, followed by your repo URL. The second command pushes your commits. Git push-u origin main. GitHub will ask you to authenticate. Sign in with your GitHub credentials. After a moment, your push will complete. Go back to your GitHub repository page and refresh. Your readme.md is there. Your project is now live on GitHub, backed up, and accessible from anywhere in the world. Branching explained simply. Here's the concept that separates beginners from intermediate Git users: branching. By default, all your work has been happening on a branch called main. Think of main as the trunk of a tree, the stable, production-ready version of your project. A branch is a parallel copy of your code where you can experiment freely without touching main. When your experiment is ready, you merge it back. If it fails, you just delete the branch. Main is never touched. Oh, create a new branch. Git checkout-b feature/my-new-feature. The -b flag creates and switches to the new branch in one command. Now any commits you make happen on this branch, not on main. Make a change, add a new file, modify something, anything. Then git add dot, the dot stages. All changed files at once. Git commit-m, add new feature. To see all your branches, git branch. The branch with an asterisk is your current one. To switch back to main, git checkout main. To merge your feature branch into main, git merge feature/my-new-feature. Now your changes are in main. Push to GitHub, git push. Your feature is live. Branching feels unnecessary on solo projects, but the habit will save you the moment you work with other people, or the moment you need to fix a bug urgently without breaking half-finished work. Cloning a repository. The last essential skill, cloning. This is how you download someone else's project, or your own from a different computer, and start working on it. Go to any GitHub repository, click the green code button, copy the HTTPS URL. In your terminal, navigate to where you want the project to live, then type git clone, followed by the URL you copied. Git will download the entire repository, all files, all commit history, everything. The project folder appears in your current directory. Navigate into it with CD, and you're ready to work. Cloning is also how you get started contributing to open source projects. Find a project you like on GitHub, clone it, make your changes on a new branch, and submit what's called a pull request, proposing your changes to the project maintainer. That's the whole open source contribution workflow in a nutshell. Reading Git history. One last thing, reading your Git history properly. You've seen Git log already, but there's a cleaner version, Git log -- online. This shows each commit on one line, just the short hash and message. Much easier to scan. You can also type git log -- online -- graph to see a visual branch diagram right in your terminal. To see exactly what changed in a specific commit, git show followed by the first 6 characters of the commit hash. Git will show you every line that was added in green and every line that was removed in red. To compare your current state with the last commit, git diff. Green lines are new, red lines are removed. These commands turn Git from a tool you use blindly into one you actually understand. That's Git and GitHub, from zero to a full working workflow. You've installed Git, made commits, pushed to GitHub, created branches, cloned a repo, and learned how to read your history. The way to get comfortable with Git is to use it on every project from now on, even personal ones, even tiny ones. The muscle memory builds fast. If this helped, subscribe to TrashToTeach and drop a comment with the first project you're going to push to GitHub. I'd love to see what you're building. Next up, how to write your first Python script to automate something boring. Because now that your dev environment is set up and your code is version controlled, it's time to actually build something. Link is on screen now. See you in the next one.